Hello, Accelerated Math 7-8 students. We are beginning Module 12, Lesson 2. And Module 12, Lesson 2 is continuing working with basic rigid motions, the ins and outs of basic rigid motions. And the focus today is on reflections. So you need to turn to the correct page in your comp book so that we can begin our notes. And our notes today are actually kind of short compared to yesterday. So let's start. The ins and outs of basic rigid motions called reflections. The goal. Today we will work with the rigid motion called reflection. The question that I want you to think about during this lesson is, what must be present in order to complete a reflection? There's a certain tool that you have to have, and if you don't have it, then you cannot complete a reflection. And so we're going to hopefully be able to answer that by the end of these little short bits of notes. So something to think about, when you look in a mirror, what do you see? Everybody should be answering a reflection, because that's correct. When you look in the mirror, you see a reflection of yourself or whatever happens to be put in front of the mirror. Well, in geometry, we also have a tool that we use to help us see reflections. And in geometry, there is a figure that allows the reflection to occur. And we call this figure a line of reflection. So when you're working with geometry, whenever you are working with the transformation called reflections, there has to be a line of reflection present. And so I put a line right here, and I actually had two really cool pictures. One was of a cactus that reflected over here, and then the cactus was reflected, and you could see how it looked different. Then this program didn't work, so then I did a cloud talking bubble, and it worked on my laptop, but then when I put it on the iPad, it didn't work, so actually I'm going to draw one. So basically what you need to think about when you are working with a line of reflection is your line sits in the middle of any picture that you're working on. So for example, let's say we had a talking bubble, okay, from a cartoon. And you know what talking bubbles look like. They look kind of like this, right? And they come off of their head when they're talking. Well, if this right here is the line of reflection, then what is happening is whatever is the figure on the left is reflected over the line of reflection so that you would have something that would look, and mind you, this is freehand, so it's not perfect, but if you used the transparency, you could get it to be perfect. It would look something like that, okay? And so a line of reflection takes whatever is on the side of the reflection and it flips it across the line of reflection, and you have the exact opposite of the picture, okay? That's called a line of reflection, okay? The true mathematical definition of a line of reflection is this. The line of reflection is the bisector of the segment between the figure and its prime. So what we're talking about, that the bisector of the segment that's between the figure and its prime. So for example, if we were to make one segment that connected, let's say these are reflected exactly the same, it would be, the line of reflection would have to show that it's right in the middle. Now my drawing is really off, okay? But you get the point that in order for this to be a true reflection, this length from here to here should be exactly the same as from here to here. So I should actually have my little book, and then everything shifted a little bit more. So, but that's what a true line of reflection is that the line of reflection is the bisector between the original figure, so figure A, we'll call this, and figure A prime. Okay, so it cuts the whole figure exactly in half. Okay, and so that your distance from every point should be exactly the same. Every point should be exactly the same. Every point should be exactly the same. So you can see I'm kind of off in my drawing, but that was trying to draw it freehand. Now there's a reason why you don't have to do that, because you have our famous transparency. Okay, so let me show you what would happen if we actually use the transparency. So you're going to draw your line of reflection, and we usually, when we have a line of reflection, it usually has an L or some kind of letter letting the mathematician know this is a line of reflection. So let's try it again. What if I drew a cactus this time so that you can see what I'm talking about? So here's our cactus, yeah? All right, So what you do is you take your transparency and you set it down and you copy exactly what you have drawn, including your line of reflection. So you're going to trace the line of reflection right here. Put your L so you can see it. Trace your cactus or whatever your figure happens to be, right? And then what you do is you pick up your transparency and you reflect it, which means that it flips over. So now, then you line up your line of reflection, and now what you do is you trace your transparency so that when you get done drawing, you will have that bisector line that it's talking about. And it doesn't have to be perfect, but as close to perfect as you can make it. You can see me doing this. So again, another reason to have those transparencies that I gave you. And so you will notice the distance from here to here is exactly the same as from here to here. They are equal. Okay? So the line of the reflection, it bisects the segment that is drawn from the pre-image to the image, using that vocabulary again. So this is the pre-image, right? Figure A prime. No, excuse me, figure A, because it's the original. The pre-image is the original. See, I even get confused sometimes. To the image, which would be A prime. Okay? And the segment is cut directly in half. If we were to draw one here and we were to draw one here, they would be exactly the same distance away. Okay? And so you have a reflection. And you notice how the picture changed. It is an exact reflection of what you see over there. Okay? So that's your line of reflection. And reflections are done. You have to have a line of reflection in order to have a reflection. Okay? I know, it's a lot of redundant words. But you take the image, you reflect it over the line, and then you are able to make a copy of the figure facing an opposite direction because it is a reflection. Okay? All right, so now let's go back to our goal to make sure that we did it. So our goal today. Today we will work with the rigid motion called reflection. What must be present in order to complete a reflection? Everybody, what must be present in order to complete a reflection? That is correct, the line of reflection. A line of reflection is the bisector of a segment between the figure and its prime. So here's the figure, here is its prime, and it cut it directly in half, like the picture shows. Okay? So you're going to be practicing a lot of those in our practice tomorrow. So I'm kind of excited for you, as long as you remember to bring that transparency. Also in class, I'm going to remind you and be kind of a big, gigantic stickler that you label everything correctly. So if this one is the pre-image, the original, and this is the image, the prime, that you have to have your prime notation written on there, okay? So it's really important that you know that. All right, that's all I have for you today, and I will see you all tomorrow. Bye!